Hi everyone. We're going to talk about arcs of circles today. An arc of a circle is just a piece of the circle. So I have a circle here centered at P with this point Q, and by moving Q I can change the radius of P. And I have these 2 points on the circle, A and B. Now the arc AB, which is denoted as AB with a little arc symbol over the top of it, is just a piece of the circle that goes from A to B. Now in GeoGebra, you can construct that semicircular arc. So here it says select the center and the 2 points, and I've constructed that arc. And so if you'll notice, I can go here to the circle, and I can hide the circle, and that arc still exists, that arc AB. Oh, so now let me get the circle back. There we go. Now, one thing you have to be careful about is when you say arc AB, that could be ambiguous, because do you mean the arc between A and B here, or the arc between A and B on the other side? So GeoGebra actually will let you construct both of those arcs. So I'm going to actually delete this arc AB, and I'm going to go back here, and I'm going to construct the circular arc, but now I'm going to choose A first and then B, and you'll notice that when I hide the circle, I've now constructed this other arc. So there's some ambiguity in how you define the arc AB. One solution to this is to talk about 2 kinds of arcs. There's the major arc, which is the larger of the 2 arcs between A and B, and then there's the minor arc, which is the smaller of the 2 arcs between A and B. So if I quickly go back here and construct this arc, then if I hide this arc and the circle, what remains is the minor arc AB, and then if I hide this arc, then what remains is the major arc AB. So that's one option. Another option is to simply put a third point here, C, and then to write this as arc ACB, and it removes some of the ambiguity. But the basic idea is that an arc is a part of a circle, and there's a minor arc, which is the smaller of the 2, and the major arc, which is the larger of the 2. Now the big question for us is, how are we going to measure arcs? So when we think about measuring things, we usually think about units. A natural idea would be to measure the length of this arc. But one problem with that is that, let's say we have this arc here from A to B, and we measured its length. Now, in some sense, this is the same kind of arc as this. But these 2 arcs will have different measure because they'll have different lengths. This will be shorter than this one. So we want a measure of an arc that tells us that this arc, which is basically a quarter of a circle, is the same as this arc, which is also a quarter of the circle. One option would be to measure arc length in terms of the circle, like a quarter of a circle, or half of a circle. We're going to do basically that, but we're going to define measure in a familiar way, and that is we're going to identify the measure of the arc with the measure of the angle made by the 2 points on the end of the arc and the center of the circle. So this is called the central angle. So this angle will be the measure of this arc. So we were actually going to measure arc measure in degrees. And so the way we write that is like this. The measure of arc AB is actually equal to the measure of angle APB. And notice that even if we switch or change the size of the circle, then because that angle stays the same, then the measure of that arc stays the same. And so this is the key to understanding the measure of arcs, that they're the measure. So arcs are parts of circles, and the measure of an arc is the measure of its central angle.